Okay, so this is going to be hopefully a quick video for doing the angles study island activity. And hurry, it's getting late here in the afternoon. So there are a bunch of things we learned in chapter 8 that we're talking about the how to find the measures of angles, and we learned some vocabulary that I'm going to go over here. So let me move my camera out of the way. We had learned that complementary angles add up to 90 degrees. So if I have two angles like this, like A and B, that are part of a 90-degree angle, A plus B is 90 degrees. The angles can be separated. One can be here, one can be over there. As long as they add up to 90, they're complementary. Similarly, supplementary angles add up to 180 degrees. So angle E and angle F, which are making a straight line, which we should know is 180 degrees, E plus F will equal 180. Then we learned about these things called vertical angles. They're not really named very well because like this angle M and angle N, those are vertical angles even though they're kind of horizontally across from each other. So the word vertical in this case is not meaning up and down. It just means, I don't know what it means. It's what it is. It's a different word. So vertical angles are going to be across from each other. In fact, if I were to add to this picture, I could call this A and this B, and now A would equal B because they are also vertical angles. So those two angles would then be equal to each other also. Then we learned that the three interior angles of a triangle add up to 180 degrees. So A plus B plus C adds up to 180. And finally, we learned four interior angles of a quadrilateral. They added up. They add up to 360 degrees. So if I have W, X, Y, and Z, W plus X plus Y plus Z will add up to, oh, there's a mistake. Those will add up to 360 degrees. Save that right now while I'm here. So, and those were kind of the main pieces of the angle part of chapter 8. Now, there are some problems that you're going to be doing in Study Island where they're going to be asking you to find the measures of angles, write equations that can be used to find angles, or match up angles that have the same measure. There's lots of things they could ask us, but this is the basic idea. So I'm going to give you a few examples here that you can use. Some of these actually might be in Study Island in the activity, so you might save these when you get a chance or write them down. So in this problem, in this figure, angle, the measure, by the way, this little M stands for measure of, and then this is the word angle, and then P to O to R. So if we go from P through O to R, that makes O the vertex. That angle is going to be 170 degrees. So measure of angle POR is 170 degrees. The measure of angle ROQ, R through O to Q, this angle right here is 52 degrees. If the measure of POQ equals X, so P to O to Q, they're going to call that, this angle right here, they're going to call that X. Which equation could be used to solve for X? So it looks like the piece that is X and the angle that is 52 are adding up to a total of 170. So if I were going to write an equation, it would be something like this. X plus 52 equals 170 degrees. Some of you might say X is equal to 170 minus 52. But when we look down here at our possible answers, there's nothing here with subtraction. So this was not going to be a good estimate. Even though it's correct, this is really what we should be looking for. And that would be problem D. x plus 52 degrees equals 170. So I'll let you pause for a moment and think about what you're doing. Make sure you understand that one. All right. Now, we didn't use any of our 5 main ideas on that problem, but I guess we could use something called adjacent angles. So adjacent angles were two angles that have a common vertex and a common ray, and one will be on one side and one will be on the other side. So angle 1 and angle 2 are adjacent angles. And the pair of them might add up to the big angle, right? So those are called adjacent angles. Or as I heard somebody in England said adjacent, which sounded really strange to me. Okay, moving on. Problem number 2. So angle AOC and angle BOD are vertical angles. As soon as you know that they tell you something are vertical angles, that's when you come back here and you say, okay, vertical angles are congruent. That means they're equal in size and shape. So M would equal N in this case. Vertical angles are equal or congruent. So I'm going to take the measure of this angle and I'm going to make it equal the measure of this angle. So we're going to write an equation, 4x plus 40 equals 120 degrees. Which equation could be used to solve for x? Well, that would have to be this one. If they ask you to solve for x, well, let's think about our math that we learned a while back. Let's take a little quick review of that. So if we had 4x and we have a 40 and we have 120, can I remove any x's from both sides? Hopefully your answer was no. But I can subtract 40 to get it away from the 4x. Right? If you put a negative 40 here and a negative 40 here, you've created a zero pair that you could throw out. So 4x is going to equal 80. And then if they ask you to solve from here, then you're going to divide this by 4 equal groups to make a giant 1. And x would be 20 degrees. Now, they did not ask us for that. They just asked us what equation could be used to figure that out. But I just wanted to be a little bit thorough for you. So if the question said, what's the value of x? And your 4 options were x equals 20, x equals, would that be 40, x equals 10, or x equals negative 3, then you would choose this one. And my last problem is a scary one. Directions. Drag the tiles to the boxes to form correct pairs. Not all tiles will be used. And here's the subdirections. Use the image shown above. Match the angles that have the same measure. Oh my gosh, there's angles everywhere. Here's an angle here. There's one here, there's one here, there's one there, here's another one. We have a lot of work to do. Now, I will tell you that this marking and this marking mean that this side and this side are equal in measure. If I have this mark and this mark, see the doubles? Those are equal. In fact, this side is also equal to this one. And this one, and this one, and this one. Anything with the 2 marks are equal. Anything with the 3 marks are equal. So when they're asking us about the angles, though, those markings might tell us something about the shapes that we have. For example, see this parallelogram right here? The opposite sides of a parallelogram are always equal. And if it's a parallelogram, then we also know that the opposite angles are equal. So if this was 108, then this has to be 108 degrees. And what I'm going to do is just start working my way around this picture, trying to come up with all of the angle values, and then we can go match up which ones are which. So if this is 54, and this angle here and this angle here have to be equal because their sides that were opposite them are equal. So I know that the angles opposite those equal sides are going to be the same angle. So there were 180 degrees inside of a triangle. So if I took 180 minus 54, I would get, what's that? 126, right? Borrow from that, make that a 10. Yep, 126. But I have to split that evenly between these two base angles. So 126 divided by 2 is 63 degrees. I know this angle is 63, and so is this angle. Now, this angle and this angle here are vertical angles, so I can say this is 63 degrees while I'm at it. And I see there's a 63 down here too. That's interesting. This angle, I'm not sure what that is. It's not necessarily 63, but I do know that the four angles of a quadrilateral add up to 360, and these two angles have to be the same because they're opposite angles. So if I said 108 plus 108, that's 216, and then take 360 degrees for the quadrilateral minus the 216. Let's see, what is that? 5, 10, 4, 144, and divide that two ways. That would be 72 degrees each. So this is 72, and this is 72. Now I do notice that this angle and this angle, they make a straight angle. See how this makes a straight line? Well, that would be 180 degrees by itself. So I'm going to take 180 minus 108, which is 72. So this must be 72. And interestingly, since this is 72, I bet you the other side here is 108. So that way it makes 180. Let's see, in here I have a triangle. The degrees of a triangle always add up to 180. So if I add these two and subtract from 180, I'll get an answer there. So let's see, 108 plus 45 is 153. 180 minus 153 is 27. This is a 27 degree angle. Let's see, what else am I missing? I need this angle right here. Here's a quadrilateral again. So that would add up to 360, or I could do this. See these three angles, this angle, and this angle. Those three would add up to 180. So I think I'm going to use those. So let's see, 63 and 72 is 135. 180 minus, I lost my pen. Minus 135 is going to be 45 degrees. So this is 45. Doesn't look like 45, but I guess it is. What else? I have all these, maybe this angle. This angle is made up of these two angles. You see this angle and this angle together are vertical with that one. So I could say that 45 plus 72 is 117. So this angle is 117. And the only one I think I'm missing is, oh, here's a 90. See how this is 90? And therefore this one has to be 90 because they got to make 180. So this is the only last corner I got to get. 63 plus 90 is 153. Oh, I saw that over here. Remember the 153? So 180 minus 153 is 27. This is a 27 degree angle. Now, when they give you three letters, the middle letter is called the vertex letter, vertex angle. So angle CDE goes from C to D to E. If I go from C to D to E, that would be 54 degrees. So I'm going to put that right here. CHI goes from C to H to I. C to H to I, that's 72 degrees. HCE, from H to, where's C? I lost it already. Oh, H to C to E. H to C to E, that's 72 degrees. JCB, JCB, that's 63. BCH, where's BCH, BCH, that's 45 degrees. EFG, EFG, that's also 45 degrees. DEC, 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 that's a 63 degree angle. And IAB, where's I? IAB, that's 27 degrees. And last, GEF, GEF, that's 27. So the ones that go together, it looks to me like, I'm going to change color here, these go together, these go together, these go together, and so do these. So it says to drag the angles. So CHI and HCE, they go together. JCB goes with DEC. BCH goes with EFG. And IAB goes with GEF. Now, your job is to go to Study Island and do the angles problems, the angles activity, and see if you can get 70% or right or better. I think you can try it as many times as you want. Good luck, work hard. Thank you for listening.